Hi dear students, I Abhinav Sir welcome you all in your own platform, that is Resultant guys. I hope we are live guys, and in this session guys we will be doing the questions of strength of material. This session will be equally helpful for civil and mechanical students and everyone. I hope all of you are super excited guys, and welcome to the first game changer series. Okay, so guys, in this series we will be doing the practice of all technical subjects, whether the subjects of civil or whether the subjects of mechanical. Okay, and this series, the level of the questions, the depth of the questions, the syllabus of the questions will be on the basis of RRB exam. Guys, I have already made a detailed video of RRB, especially for civil engineers, that what is the cutoff, what is the expected cutoff, what are the number of seats, what are the number of seats last year, how they should be preparing, what are the vastness of the syllabus, what are the extra syllabus, what is the weightage of the previous syllabus. Each and everything I have made already a video that is available in this channel, the green color thumbnail video. In the recorded mode you can see that. Okay, so guys, I hope everyone is doing fantastic, and let me go further. Those who don't know me guys, let me introduce myself. My name is Abhinav Sir. I have done my MTech from IIT Delhi, got all India rank 164 in GATE 2012, and this is my email ID. If you want to connect me, abhinav@resultant.in, or you can connect me in my WhatsApp number here or in my Telegram group Civil by Abhinav Sir. Okay, so guys, these are our faculties for civil who will be dealing with the RRB guys. Me, Vikas sir, Richa ma'am, Joshi sir. Okay, we have the courses also guys for CBT1, the non-tech part. Okay, because I told you the distribution of non-tech also, 55 marks in the non-tech out of 100. CBT, which is of 100 marks, out of this 55 is reasoning and aptitude. That is particularly for civil engineers the favorable part, and 45 marks is GS and GA. 45 marks guys, Khushbu ma'am will be taking for you, who is the expert of these subjects, particularly for the railway exams, and 55 marks Richa ma'am. And let me tell you, one more faculty will be coming soon, will be taking that. So complete CBT1 course is there for rupees 2499. Similarly guys, CBT2, if you don't want CBT1 course, only the CBT2 course, then that is in 5499. And if you want similarly for mechanical also, for the same price, CBT1 and CBT2 is there. And if you want the complete batch CBT1 and CBT2, then this is the mission batch for mechanical. Okay, same, the mission batch is for civil also. Same, the mission batch is for civil also, CBT1 and CBT2. So either you can go for the focus batch, particularly for CBT1, or aim batch for CBT2, and mission batch for CBT1 and CBT2. This is for both civil and mechanical. Okay, for civil and mechanical guys, this is the price guys for CBT1, CBT2, and that is CBT1 plus CBT2, that is mission batch. You can also connect me guys on my Telegram, Civil by Abhinav Sir. Already guys, more than 6,200 students have joined there. They are asking their queries and getting the content. If you want, you can also join there. Hi Kedari, how are you? Hi Jaydev. Everyone guys, please put a thumbs up. Are you ready? And guys, please, my humble request that please guys take a copy and pen along with you. Okay, so that you can do practice simultaneously. Okay, okay. Okay. Any doubt? Any doubt? Shall we start? विकास क्या कह रहे हैं? मैकेनिकल, यस, मैकेनिकल इंजीनियरिंग स्टूडेंट्स ऑल्सो वेलकम गाइस. सोम इज फॉर सिविल एंड मैकेनिकल बोथ. सोम इज फॉर सिविल एंड मैकेनिकल बोथ. चलो, दिस इज द फर्स्ट क्वेश्चन ऑन योर स्क्रीन गाइस. दिस इज द फर्स्ट on your screen. Okay, दादू को चाबी दे दो, दूध जाओ, दादू को चाबी दे दो, इसका दूध वहां रखा हुआ है। ओके, व्हाट इज द बल्क मॉडुलस? टेल मी एवरीवन ऑन द कमेंट सेक्शन। चलो गाइस फटाफट। बल्क मॉडुलस इज डिफाइंड एज सिग्मा बाय वॉल्यूमेट्रिक स्ट्रेन, एप्सिलॉन वी। बल्क मॉडुलस इज sigma by volumetric strain is delta V by V. Bulk modulus is delta V by V, sigma by volumetric strain. Also, one more thing guys, can you tell me for this question that, guys, let me again tell you here in this batch, that is the what is the name of the series? Game Changer series. Okay, the questions will be up to the JE level, okay, particularly RRB. Now one more thing guys, can you tell me K of rigid body? What is the K of rigid body? What is the bulk modulus of rigid body? Guys, because we don't know na. If I have made a question, Abhinav Negi has made a question, that doesn't mean the same question will be asked by RRB. Okay, they can ask a related question from this. What is the value of rigid bulk modulus of rigid body? Tell me. Bulk modulus of rigid body, guys. See, volumetric strain will be 0. Volumetric strain will be 0. Okay, volumetric strain will be 0, so K will be infinite. Because guys, in rigid body nothing can be changed, na? So always remember one thing: bigger is the K value, more is the rigidity or solidity of the body. Okay, what is K of incompressible body? Tell me this also. K of incompressible body. What is the value of K for incompressible body? For incompressible body, again guys, there will be no delta V. Volumetric strain will be 0. Volumetric strain is delta V by V. So there is no volumetric strain. So it will be 0. So K will be infinite for that. Give me yes or no. Give me yes or no. Tell me. Let me go to the next question. Direct stress to the volumetric strain. Do this one. A circular bar of diameter 50 mm is subjected to pull of 50 kilonewton. There is a circular bar of diameter 50 mm is subjected to a pull of 50 kilonewton. Okay, diameter of this is 50 mm. Diameter of this is 50 mm. Poisson ratio is 0.33. The mu value is 0.33 and Young's modulus is 7.07 into 10 की power 4 Newton per mm square. What is the value of shear modulus? This is asked. This is asked. So guys, we all know that E is equal to 2G 1 plus mu. Now when we are writing this, E value is given. Okay, E value is 7.07 into 10 की power 4. In guys CB2, let me remind you, calculator is allowed. Calculator is allowed, guys. Okay, so don't be afraid of this calculation. 1 plus mu means 1 plus 0.33, and E unit is in Newton per mm square. They are also asking here Newton per mm square. So from here, guys, you can find out the value of G. How much you are getting, guys? Come on. How much you are getting, guys? Come on. From here, guys, the G value will be getting as 2.67. You will be getting 2.65 into 10 की power 4. 2.65 into 10 की power 4 Newton per mm square. Everybody, guys, please like and share the session. Now, next question: the strain energy of a pin jointed structure. A structure where the members are jointed by pin. Okay, a structure where the members are jointed by pin. What is the strain energy stored in a pin jointed structure can be expressed as, this value is F square L by 2E, summation of F square L by 2E for all the members. Suppose there are, guys, more than 3 members or more than 2 members, 3 members, then summation of F square L by 2E, that is F square L by 2E for each and every member. Next question: the Poisson ratio of a material is 0.3, Young's modulus is 200 gigapascal. What will be its modulus of rigidity? Just now, guys, we have done a question that E is equal to same formula, guys. Why I am doing this? Because in 2019 and even before that, the questions among almost all the zones have been asked from this formula. That is why I have taken this. Okay, so now from here, what is E? E is equal to 200. 2 into G, 1 plus 0.3. So G value is equal to 200 upon 2.6. When you do 200 by 2.6, so value you will be getting as 77 gigapascal. Value you will be getting as 77 gigapascal. Okay, guys, from this formula, guys, let me tell you, more than 10 zones, more than railway 10 zones, the question have been asked. From more than 10 zones, the question have been asked from here. Okay, now let us move further, guys. This is little bit tricky, guys, little bit tricky, but I hope you can do this. I hope you can do this, guys. Little bit tricky, but I'm quite sure that you will be hitting it. But I'm quite sure you will be hitting it. Come on, come on, come on, everyone here. Everyone, guys, come on. Okay, the ratio of modulus of rigidity and modulus of elasticity of this is asked of any isotropic material. Guys, before we solve this question, why I have taken this? Because, guys, in various zones this question is asked. Please tell me, what are the total number of elastic constants? One more question. One more question. What are the total number of elastic constants? 4. What? How many are independent? How many are independent? 2. For isotropic material. For isotropic material, number of elastic constants are 4. What are those 4? Young's modulus, normal stress by normal strain for unidirectional loading, G, shear stress by shear strain, mu, Poisson ratio, and bulk modulus. Now, what is the meaning of independent are 2? What does this mean? Independent 2 means that there are the formulas. If you know any 2, then you can find remaining 2 also, because there are relation between, or the formulas between E, G, mu, K. If you know any 2, those any 2 can be these 2, these 2, these 2, this and this and this, anything. From any 2 you can find remaining 2. Okay. Okay, Anas, we have circulated a Google form, and as per your demand, guys, of course YouTube is for free, na? So as per your demand, if there are sufficient number of Hindi students, guys, not only will be dealing in Hindi, but also we will be opening a batch for them as well, if you want. And if you want that, no sir, we want Hindi only YouTube classes, nothing about batch, then we can take YouTube classes also in Hindi. So there is a Google form in the description box, please fill that. Now guys, what is G by E? From here, the G by E value is equal to 1 by 2, 1 plus mu. Now guys, for maximum value, G by E maximum value, what will mu should be minimum? Actually mu can be minimum -1 also, na? But all values are in positive. For human tissues and soap polymer, mu is negative. So here I will be taking it 1 by mu is 0 for metals. Okay, so it is maximum value. When mu is minimum, it is maximum. Now G by E minimum is when mu is maximum. So mu maximum is 0.5 for rubber. So 1 upon 2, 1 plus 0.5. So 1 upon 1.5 into 20 will be 3. So it will be 1 by 2 to 1 by 3. So both A and C, no, it maximum value is 1 by 2. Maximum value is 1 by 2 and sorry, it will be varying from 1 by 3 to 1 by 2. Okay, so more than 1 by 3, yes, C is the correct answer. It will be more than 1 by 3 and less than 1 by 2. So actually A, yes, D will be the correct answer. D will be the correct answer, A and C. Got it? Got it? Yes, Julia. Can you all please write down your cities also, from which part of the country you are? And let me tell you guys that Tuesday, Thursday, Saturday will be the aptitude class, 10 a.m. aptitude class by Richa Gupta ma'am. And guys, Monday, Tuesday, Wednesday, Thursday, Friday, it will be at 7 p.m. It will be GA and GS class by Khushbu ma'am, Khushbu Chaturvedi ma'am. This is I am telling you YouTube plan. So Monday, Tuesday, Wednesday, Thursday, Friday, 7 p.m. it will be Khushbu ma'am class, and Tuesday, Thursday, Saturday, 10 a.m. will be aptitude class. Okay. Now this one guys, this again same, so you can do it in homework. Now this one, which type of the cross section can attain yield movement but not the plastic movement before failure of plate buckling? That material where it can attain the yield movement but before plastic movement it is failing. Actually most of the materials fail after it comes in the plastic region, but that is failing before that. So that is called as semi-compact section. Okay, that is called as semi-compact section. Now a uniform bar of length L, there is a uniform bar of length L, cross-sectional area A and density rho is suspended vertically from one end. What will be the elongation? Guys, there is no load. There will be no load. That means they are asking the deflection due to its self weight. Okay, so what will be delta? Guys, delta due to self weight is WL by 2A na. WL by 2A na. What is W? If density is rho, so rho is mass by volume. Rho is mass by volume. What is mass? Mass is weight divided by gravity and volume is A into L. So W is equal to rho G into A into L. So from here delta value is rho G A L square upon 2AE. So it will be rho G L square by 2E. That is option number A. That is option number A. Have you got it? Please give me yes or no, everyone on the comment section. Everyone on the comment section. Please give me yes or no. Please give me yes or no, please. Okay, great. Everyone got it. Now this is again a homework guys. All those questions that I'm giving you in the homework. All those questions that I'm giving you in homework. Please let me know your answers on the comment section. Okay, this one. Bending, compressive and tensile respectively are calculated based on, this is guys compression na, when anything is compression, so gross area will be resisting for that. But in case of tension guys, only the net area means gross area minus holes or gross area minus reduction, only the net area is taken care of. Okay. So let me again tell guys, suppose this is a material na and this is a hole. So when you are doing a compression na, then whole of the area is affected or resisting the load. But yes, when there is a hole like this and you are applying the tension, so only the net area means whatever is available, only this net area is taking care of the load resistance. This is gross area. Okay. What is the neutral axis? What is the neutral fiber? Neutral fiber is the layers do not undergo any strain. Okay, neither compression nor tension. Now again guys, there is a myth among students that above the neutral fiber there is compression and below the neutral fiber there is tension. That is only for sagging movement na. If this is a beam and we are applying the movement like this, then this is in compression and this is in tension. But if the beam is like this and you are applying the hogging movement, okay, then this is in tension, this is in compression. Tension can be at the top also, and there will be a member where neither the length is increased or decreased. That will be the neutral fiber or neutral axis. Okay, do this one. What do you mean by a beam of uniform strength? What do you mean by the beam of uniform strength? What does it mean? What does this mean? A beam of uniform strength. A beam of uniform strength means that same maximum bending stress at every section. Okay, same maximum bending stress at every section guys. Okay, same bending stress at every section. When a cantilever beam, suppose let me draw a cantilever beam. This is a cantilever beam like this. In this cantilever beam, at free end, the when a cantilever beam is loaded at its free end, suppose this is loaded at its free end like this, then the maximum compressive stress shall be, obviously guys, after applying the load it will be going like this, hogging. This will be hogging. In hogging, tension will be here and compressive will be at the bottom fiber. So compression will be at the bottom fiber. Got it? Everyone? Got it everyone? Any doubts, please tell me. No doubt. In a simply supported beam, this is a simply supported beam like this. In a simply supported beam, what they are asking further? A uniformly distributed load is acting on the entire span. A uniformly distributed load is acting on the entire span. So after load it will be deflected like this. So where the slope is maximum? Guys, what is slope? Draw the tangent and the angle from original position. So like here, draw the tangent, original position horizontal. So this is the slope. Okay. Similarly here, draw the tangent, angle from original position. This is the slope. So where is the maximum? Maximum angle is at the ends na. Maximum slope is at the supports na guys. Give me yes or no. Give me please yes or no. Everyone tell me please. Castigliano's first theorem is applicable for when principle of superposition is valid. Principle of superposition means, suppose in a bar, if you apply P1 load, now in this bar, if you apply P2 load, so if we sum this, the effect will be same as if in a single go we are applying P1 plus P2 load. So that is principle of superposition. That if in a bar I apply P1 load, if in a bar I apply P2 load, then the net effect will be same if I apply P1 plus P2 load in a one go. In that case, Castigliano's theorem is valid. Now unit load, guys, in JE exam, SSC JE exam, around 8 lakh students give the exam. Around 8 lakh students register for the exam, all branches. Okay, but if I talk about RRB JE, due to huge vacancies and due to not the form is not coming every year, after a gap of 4 to 5 years it generally comes. This year again, last time the notification was 2018, the exam was conducted in 2019. Okay, so after that now the exam is in 2024. So here guys, last time around 26 lakh students have given the exam, because this is not annual. This, I cannot say SSCGE also annual, this is almost annual. Okay, but the syllabus of civil engineering, I am not saying depth may be same in both, a little lesser in RRBJE, but syllabus of RRBJE is much more syllabus than the SSCGE. Okay, like structures is not asked in that much, not more topics in SSCGE, but here it is. AutoCAD not in SSCGE, but here it is. Engineering mechanics not in SSCGE, but here it is. Superstructure, substructure designing not in SSCGE, but it is here. Okay, so fabrication, maintenance, all these topics which are not in SSCGE and other JE exams, but it is in RRB. So not going very deep, but yes, the horizontal, they are going very wide range of the topics. So it is based on the Castigliano's theorem. Now, what they are asking, a rectangular beam 200 mm wide and 400 mm deep. There is a rectangular beam 200 mm wide and 400 mm depth. Okay, now this is over a distance of 4 meters and carry UDL of this. Determine maximum shear stress acting on the beam cross section. Tell me please. Now a rectangular beam 4 meter, as a distance of 4 meter, carries a UDL of 40 kilonewton meter. 40 kilonewton meter, and this is 4 meter. By default guys, if nothing is mentioned in the question, you have to take simply supported. In other exams they give, but in RRB they have not given the supports and the type of beam, that you have to take it simply supported beam. Now guys, here what is the maximum shear force at the support? So V is equal to WL by 2. Okay, so this value is 40 into 4 by 2 is equal to 80 kilonewton. Is equal to 80 kilonewton. And what is tau max? Tau max for rectangular case is equal to 3 by 2 of tau average. So 3 by 2 of tau average. What is tau average? Shear force by area. What is shear force? 80 kilonewton. So multiply by 1000, because the options are in Newton. Upon area. Area of this is 200 into 400. 200 into 400. So this is 3 by 2. 200, say this will go 5 times, and 5 2 it will go 80 times. Okay, so it will be 1. So it will be 1.5. It will be 1.5. Any doubt? Please let me know. Any doubt guys? Please let me know if you have. If no, then we'll go further. Now again same, you can do this. Do this one. A beam of triangular cross section. Now it is not a rectangular one. It is a triangular cross section. Suppose this will be B, the base of this, and height is suppose H. Height is suppose H. Now here in this, the maximum shear stress is where? The maximum shear stress is in the case of tau max. In the case of this, it is at H by 2 mid depth. The maximum is at mid depth. And where is neutral axis? Centroidal axis. So neutral axis is 2H by 3. This is neutral axis. So neutral axis is at 2H by 3 distance. Neutral axis is at 2H by 3 distance. Correct? So where it is the maximum intensity? Above the neutral axis. The maximum intensity is not at neutral axis here. Tau max is at H by 2 and this is 2H by 3. Give me yes or no please, everyone. Everyone please. Have you understood? Have you understood? Okay. Now going further, a beam of uniform strength at every section is maximum same bending stress. This we have done already. What is radius of gyration? Radius of gyration is, anyone can tell me on comment section? Radius of gyration is under root I by A is equal to under root pi d4 by 64 into area. Area is pi d square by 4. So from here guys, the radius of gyration d4 will be d left, pi to pi cancel, d by 16. So d by 16 under root will be d by 4. B option, d by 16 under root will be d by 4. Correct? Okay. Now in case of pure bending, the beam will bend into an arc of an, guys, we know that m by I is equal to E by R. Okay, so 1 by R is equal to m by EI. If it is pure bending, so this m will be constant and it is EI also constant. What is EI? EI is called flexural rigidity. Guys, see, this question is also asked in various JE exam. What is AE? This they have asked in various JE exam. This is axial rigidity. Why AE is axial rigidity? Why AE is axial rigidity? Because when we apply the load on a bar, axially we are applying the load on a bar, then deflection is PL by AE. So if AE is more, then deflection will be less. If AE is more, deflection will be less. In this case of axial loading. So if AE is more, deflection less, so AE is more, less deflection, so it is providing rigidity. Similarly guys, EI is called flexural rigidity. Why EI is flexural rigidity? Because guys, every slope and deflection formula, delta is PLQ by 3I, EI denominator. Okay, WL4 by 8EI, EI in denominator. So EI is more, so deflection due to bending will be less. So EI provides flexural rigidity. Similarly, what is torsional rigidity? GIP. GIP is torsional rigidity. Okay, why? Because angle of twist in case of when we are twisting, what is phi TL by GIP? When we are twisting, what is phi TL by GIP? If so GIP is more, twist will be less. So GIP is providing torsional rigidity. Okay. So if a beam is pure bending and EI is constant, so this is constant. So 1 by R is constant means R is constant. So R is constant means it will be a circle. For circle radius is constant. Let me tell all the civil and mechanical engineers again that Tuesday, Thursday, Saturday 10 AM Richa ma'am will be teaching aptitude and reasoning. And all days, Monday, Tuesday, Wednesday, Thursday, Friday, 7 PM, Khushbu Chaturvedi ma'am will be teaching GA and GS. Okay? Will be teaching GA and GS. Yes or no? Okay. Now this one. Which type of support prevents the movement of support in E3 direction? Ball and socket joint, guys. Ball and socket joint is that neither you can move in X, Y and Z direction. The pure bending moment on a section is maximum when shear force is, guys, see, bending moment is dV by dx. V I am writing as shear force. So this is maximum when shear force is 0. dy by dx is 0, we say na the function is maximum or minima. Okay, so bending moment is maximum when shear force 0. Shear force 0 means changes sign. Whenever it is going from positive to negative, it will be going from 0 na. Whenever it is going from positive to negative, it will be going from the 0 na. Okay. Similarly, the point where bending moment changes direction, in a beam carrying load is called as, so guys, when bending moment changes sign, it is called point of contour flexure, and that is very unique point. Why? Let me tell you. Guys, if suppose the bending moment here is positive and then negative. So here it is sagging, the beam is sagging here, and here it is hogging. Now concrete is generally weak in tension. So here the tension is bottom, so we'll be providing reinforcement at the bottom. Here the tension is the top, we'll be providing reinforcement at the top. So guys, this is the reinforcement. In sagging, it will be bottom. In hogging, tension is at the top, reinforcement is at the top. So that is why this point of contraflexion is very important point. The point of contraflexion is very important point, because this is the point from where we get to know that where we have to cut the reinforcement and change the direction. And the same point where the bending moment changes sign is point of contraflexion. Okay, and the same point, if I the same point where bending moment is changing sign, same point I show in deflected curve, that point is called as point of inflection curve. Okay, so point of contraflexion and point of inflection are same guys, but point of contraflexion is in BMD and point of inflection is in deflected curve. Okay. Now when shear force at a point is 0, the bending moment at that point is, when shear force at a point is 0, what is the bending moment? I just told it is maxima or minima. Either it is maxima or minima. Got it? At a hinge in a beam, at a hinge in a beam, at a hinge, guys, my hand is a hinge. It cannot resist movement na. If somebody like this, it will be folded. If somebody put like this, it will be like this. It cannot resist movement. It can resist the force. Somebody do like this, it will be resisting me. Okay, it is resisting. But if I apply a couple, it will be not like this. I am not in circus. But yes, if somebody apply movement, it will be bending like this. But yes, it will provide the axial rigidity. Okay, so hinge cannot provide the internal movement, that is bending moment will be 0 there. The point of contraflexion is also called as, the point of contraflexion I just told you is point of inflection. The point of contraflexion is also called as point of inflection. The flexural rigidity is, I told you flexural rigidity is EI, torsional rigidity is G into IP, and axial rigidity is A into E. In a fixed beam at the fixed ends, this is a fixed beam, this is a fixed beam. In a fixed beam at fixed ends, what will happen? Let's see, if I apply a load or UDL or whatever, the deflected shape will be like this. So here neither the deflection, because it can provide the vertical load reaction na? So zero deflection, and also it can provide the movement also. It can provide the movement also. So here it is not bending also. It is not bending also. So slope and deflection both are 0. Slope and deflection both are 0. Okay. So thank you guys. Again I am telling you 7 p.m. Khushbu ma'am will be teaching you GE and GS. One of the finest faculty and the expert of the subjects. Thank you. Thank you guys. I hope you enjoyed this session. Thank you all. Take care. And if you want to enroll in our courses, then as I told you guys, we have the course for civil and mechanical students. Our complete team is there. For civil guys, there is a focus batch. For mechanical also, there is a focus batch for CBT1. Okay. Similarly, there is a AIM batch for CBT2. Similarly, AIM batches for mechanical also. And if you want CBT1 and CBT2 both, there is a mission batch. Okay. These are for civil and mechanical both. Focus batch is for CBT1, AIM batch for CBT2, and mission batch for CBT1 and CBT2 both. Okay. So all the links are in the description box. If you want, you can see them. Thank you guys. Take care of all. Thank you everyone.